Hello students, in this session we will do next 11 sums from the chapter Some Basic Concepts of Chemistry. These 11 sums will also be related to the concept of mole that we have learned, and then we will do some sums that are related to the concept of molarity, molality and all those stuff. Okay, so we will do like the next 11 sums. You should be clear with all the 13 sums that we have seen earlier. Now we will see the 14th question. So in this question they have given us this question will also be little bit tricky. Let me do it. So in this question they have given specific volume of cylindrical virus particle is 6.02 into 10 power minus 2 cubic centimeter per gram. Okay, cc actually means centimeter cube. Fine, so this is a kind of short notation that they write for centimeter cube. Got it? So this is like a abbreviation. So cc per gram, which means centimeter cube per gram, whose radius and length are 7 Armstrong and 10 Armstrong respectively. Fine, so I have got the radius of radius and then the length of the virus particle, which is cylindrical in shape. So if I know the radius and then the height or length, I'll be able to calculate the volume. That will be handy because here they have given us a specific volume, right? Let me tell you what is meant by specific volume in a minute. So now I have got radius and then the length. If Na number of particles, this is the Avogadro number 6.02 into 10 power 23, they have given us the Avogadro number, which we already know. What they are asking us to find is find the molecular weight of virus. So I need to find the molecular weight of this particular virus. They have given us the specific volume and then the radius and then the length. They have given us the dimension. So what is meant by molecular weight? If 1 mole of this virus exists, then what will be the weight of that virus? That's what I need to get over here, right? For the 1 mole. If you look at the option, they have given you like 1.5, 15.4 kg per mole and all those stuff. Now to get the 1 mole molecular weight of the virus, what will I have to do is first I'll have to figure out what is the weight of one virus. If I know the weight of one virus in terms of gram, if I just multiply 6.02 into 10 power 23, if I know the weight of one virus, just multiply it with the Avogadro number, you will end up getting the molecular weight of that virus, right? So logic should be clear. If I know the mass of one atom, just multiply it with Avogadro number, I'll end up getting the mass of 1 mole of that particular atom, right? So carbon was something, so 12 gram was equal to the molar mass of the carbon, right? So that's how I made the argument. You should be clear with that idea. Same way I'm just going to do it over here. I am just going to find the mass of one virus particle. If I know the mass of one virus particle, then obviously I'll be able to get the molecular weight of that virus, right? So the logic should be clear. Same thing, only part is here the mathematical solving will be much more in depth. Okay, let me do the solving. So here I'll have to get the volume of the virus first to find the mass, right? So let me figure out the volume over here. What will be the formula for the volume of the cylinder? Cross-sectional area, that will be pi r square into the length or height. So here the volume will be equal to pi r square. That will be the cross-sectional area of a cylinder. You should be clear with this basic formula, pi r square into L. So L will give me the height over here, right? So if I do the solving, you will have, instead of pi, let me substitute 22 by 7 because you do have 7 in radius, that will get cancelled out. 22 by 7 into radius. See, if you look at the specific volume over here, they have given it in centimeter cube, right? Therefore here also, instead of changing this to meter, I'll change it to centimeter. So if it was like meter, it will be 7 into 10 power minus 10 meter, isn't it? In this case, if I change it to centimeter, you'll have 7 into 10 power minus 8 centimeter, right? Logic should be clear. If it was meter, then that's going to be 10 power minus 8 into 10 power minus 2. So that's 10 power minus 10. Here, I'm just going to change it to centimeter. Therefore, you'll have 7 into 10 power minus 8. Got it? It should be clear. So 22 divided by 7 into 7 into 10 power minus 8 into 7 into 10 power minus 8. This will give you the r square into the length. What should be its length? 10 into 10 power minus 8. That will give you 10 power minus 7. Fine. And the final answer will be in centimeter cube. Okay, that will be handy while solving for the specific volume. Got it? Now let me do the Cancelling, if I do the cancelling, 7 will get cancelled out. Then what am I left with? 22 into 7, isn't it? Yeah. So if I just do the multiplication, you'll have 22 into 7. Yes, right? That will be like 14, 154. Okay. So here you'll have 154 into, here you've got 10 power minus 7. Here you've got like 8, 8, 16. So that's going to be 23. 154 into 10 power minus 23. Okay. So here you'll have 154 into 10 power minus 23 centimeter cube. Okay. Centimeter cube. Now I have found the volume over here. Next, what I should find is, I just need to get the mass of one virus, right? So to get the mass of one virus, what they have given over here is actually the specific volume. Now let me explain the difference between specific volume and then the density. Got it? So from the units, it should be clear. If it was like density, we already know density is nothing but the mass divided by volume. We should have known this one. So mass by volume is density, which means mass occupied per unit volume. If I take like 1 unit volume, what will be the mass for that particular substance? That is what is meant by density. Here it is like the other way around. Okay, specific volume which means volume occupied for 1 unit mass. It's exactly the reciprocal of the density that will give you the specific volume, right? Got it? Anyway, if you just flip it, you'll end up getting the density. But whatever they have given us, we will be able to solve it straight away itself. So here they have given you the specific volume, which is nothing but the volume divided by the mass. Okay. If I do write that stuff, you'll have volume divided by mass, that was equal to some number that they have given over there, which is 6.02 into 10 power minus 2. Okay. So you have got 6.02 into 10 power minus 2. So this is the specific volume. By the way, I just found the volume of one virus particle, which is 154 into 10 power minus 23, isn't it? So here, if I do equate this one to the volume, so this is the specific volume, right? So volume divided by the mass. Here I'll have to get the mass. I know the volume, right? So instead of volume in the numerator, let me substitute the volume of that one virus particle, which is 154 into 10 power minus 23. That will go to the numerator. Same way, in the denominator, you will get the mass of that. You'll have to divide obviously by the mass of that one virus particle, isn't it? Got it? So you should be clear with this equation that I framed over here. So they have given you the specific volume. Specific volume is nothing but the volume divided by the mass. Here in the numerator, I have just plugged in volume of one virus particle. From that, obviously in the denominator, it should be the mass of one virus particle, right? So if I just interchange this one, I'll end up getting the mass of one virus particle. So the mass of one virus particle will be equal to, yes, m divided m, which should be equal to 154 into 10 power minus 23 divided by 6.02 into 10 power minus 2, right? Now I have got mass of one virus particle. What I am supposed to find is, I just need to get the molecular weight of the virus, which means mass of 1 mole of virus. If you have like 1 mole of virus, then what will be the mass of that virus? That is what is meant by molecular weight or molecular mass, isn't it? So to get the molecular mass of the virus particle, I'll just have to multiply this entire term by 6.02 into 6.02 into 10 power 23, isn't it? So here this is mass of one virus particle. So to get the molecular mass or molar mass, let me notate it with capital M. What will I do is, I'll just have to multiply 6.02 into 10 power 23. So 154 into 10 power minus 23, that will be in the numerator. Same way the denominator will have 6.02 into 10 power minus 2 times the Avogadro number, which will be 6.02 into 10 power 23, isn't it? Okay, now let me do the solving. If I do the solving, 6.02 into 6.02, these two things will get cancelled out. Then I'm just left with 10 power minus 2 and then the 10 power, yeah. So here these two stuff will get cancelled out and you will have like 10 power minus 21, isn't it? Okay. So by the way, if 10 power minus 21 and these two things, if those two stuff get cancelled out, 10 power minus 21, and here you'll have 10 power 2, isn't it? Yeah. So the molecular weight or molecular mass of the virus will be equal to m will be equal to 154 into 10 power 2. Okay. So here the entire convention was in gram. Got it? Yes. So the entire convention was in gram because when you look at the specific volume, it was given in gram. Therefore, here the answer will be in gram per mole. Now I have found the molecular mass in terms of gram. If you look at the option, they're asking us to find in terms of kgs, and therefore I'll have to move the decimal places. If I do move the decimal places, I'll have 15.4 kg per mole. So the molecular mass capital M will be equal to 15.4 kg per mole, right? You should be clear with this question, right? So the answer is option 1. Option 1 will be my answer, right? You shouldn't have any doubt in this question. This is a little bit lengthy one with respect to the mathematical solving. Fine, so this will be a time consuming question in the examination. So to solve this sum, what we did is we just found the volume. From the volume of one virus particle, from the volume, I just matched it with the specific volume that they have given in the question. For my easier solving, I took everything in centimeter cube. Therefore, I just got the answer straight away, mass of one virus particle in terms of gram. Got it? So once I get that mass of one virus particle, just I'll have to multiply it with the Avogadro number to get the molecular weight of the virus particle, right? You shouldn't have any doubt on this question. It should be clear. Let's move to the next one. Next question is, an organic compound contains carbon, hydrogen, and oxygen. Okay, so here you have got an organic compound which has carbon, hydrogen, and oxygen, obviously. Its elemental analysis gave C to be 38.71 percentage. They have given you some percentage. Same way they have given us for hydrogen also. Fine. They haven't given anything for oxygen. Then obviously out of 100 percentage, 38.71 was like carbon, and then hydrogen was like 9.67. Rest all other percentage will be for the oxygen. Fine. What they're asking us to find is the empirical formula of the compound would be. So I just need to get how much percentage of carbon, hydrogen, and oxygen will be there, so that I'll be able to get the empirical formula. So in empirical formula, I do not know in what fashion the carbon has attached to the oxygen and things of that sort. Only thing that I know is I just know this much amount of carbon is there, this much amount of hydrogen is there with respect to the oxygen in terms of the moles, okay, or in terms of individual entity or atom. Got it? Fine. So to get that answer, here first I'll have to fix this one. They haven't given this percentage in terms of moles. They have given us in terms of mass. Fine. So generally when you do the elemental analysis, you'll get like 38.7 gram or kg of carbon with respect to 9.67 gram of hydrogen. Then rest all other gram will be for the oxygen, right? So gram will be the suitable convention for doing the experiment. Therefore, the measurement will be in terms of gram. So once I get the answer in terms of gram, I'll be able to get the moles out of it. If I get the moles, then I'll obviously be able to get the empirical formula, right? Let me do it. It's an easy one. Fine. First, let me find out what percentage of oxygen is there in this mixture. Okay, so to get that percentage, what will I do is, yeah, for the carbon, it was like 38.71, isn't it? If I do add those two stuffs, 38.71 and then 9.67, isn't it? So if I do add these two stuff, we will have like 8. So this will give you 13, 1. So this will be like 18, 1. So 48.38. So together combined with carbon and hydrogen, you have got 48.38 gram out of the 100 gram that I've taken. 48.38 gram will be the combination of carbon and then the hydrogen. Rest all others should be for oxygen, isn't it? So to get for oxygen, I'll have to subtract it with 100. So out of 100 grams that I've taken, 48.38 will be used by the rest element. So for oxygen you will have, so this will be like 10, therefore you will have 2, this will be 9, isn't it? So for the 9 you will have 6, point. Here for the 9, you'll have like 1, and this will be like 5, isn't it? 51.62. So the percentage of carbon that will be present is 51.62, which means in 100 gram of this mixture, 51.62 gram of oxygen will be there, 9.67 gram of hydrogen will be there, same way 38.71 gram of carbon will be there. So this is the elemental analysis for this organic compound. Now I'm just ready to get the empirical formula out of it. So to get the empirical formula, I'll have to know in terms of moles, isn't it? So for carbon, it will be 38.71 gram divided by the molar mass of the carbon. What is the molar mass of the carbon? That's going to be 12 gram, isn't it? 12 gram. Got it? Same way. Yeah. Let me move this one a little bit towards the left. So this was the molar mass of the carbon. Same way, if I do cancel this one, I'll end up getting the number of moles, isn't it? Yeah. Let me do the cancelling steps. So what will be 12 times 3? That's going to be 6, 36, isn't it? Yeah, 36. So you will have 3 point, yeah, it's going to be 36. So that's 7, isn't it? 27. So that will be like 24. So 3.2 moles. Got it? So for the carbon, you will get 3.2 moles. Okay. This one is done. 3.2 moles of carbon will be there in 38.71 gram. Then let me find it for the oxygen, I mean hydrogen. Then for the hydrogen, they have given you 9.67 moles, isn't it? So 9.67 gram, 9.67 gram divided by, for the hydrogen, that will be 1, isn't it? So this will give you straight away 9.6 moles. So for the hydrogen, you will have 9.6 moles. Here it is not diatomic, only the hydrogen atom. I'm just considering only one atom, okay? It is in the combination with the organic compound, okay? So I'll have to consider only as a single entity or atom. Then you have got the oxygen. Next, for the oxygen, you will have, you have got like 51.62, isn't it? So 51.62 gram divided by 16 for the oxygen. Yeah, right? If I do the solving, you will have, yeah, let me compare it with 3 multiples of 3. So 16 into 3, that will give you 8. 1, that will be like 48. Okay, so 3.48. So this two will be closest approximation to 2. Therefore, next one has to be like close to 2. So that will give you 3.2 moles. Fine. Now I have got 3.2 moles. Got it? So now I'll have to get the ratios for this one. So if I have to get the ratios for this one, carbon and oxygen seems to be in the same proportion. Therefore, let me divide this entire moles by 3.2 so that I'll get in the multiples of 1 or 2. Okay, that will be easy to get the empirical formula, right? So now let me divide the entire term by its lowest term. If I divide this one by 3.2, I'll get 1. So if this was present in 1 mole, then obviously this one carbon will also be in the same proportion, that will be equal to 1, but hydrogen will be available triple the times than this one, right? So if I divide this one by 3.2, it should be clear. So 3 into 3 will give you like 9.6. So in that ratio, so obviously you will have like 3. So here when you look at this one, I'll be able to get the empirical formula, isn't it? If carbon was available in terms of 1, which means if one carbon atom was there, you have like 3 hydrogen atom in it proportionally triple the times of hydrogen will be there because I've compared in terms of moles, isn't it? Same way oxygen will be there in the same proportion to that of the carbon, which means CH3O. Got it? So the empirical formula over here should be like CH3 and then the O. If carbon was double the amount, then you will have like C2H6O2. So this is how it's going to increase, right? But in this situation, I do not know in what combination carbon, hydrogen, and oxygen has actually bonded. Only if you do like molecular analysis of all those stuff, I'll be able to get the molecular structure behind it. But in this situation, it is pretty clear that for one part of carbon, you have got like 3 parts of hydrogen and then one part of oxygen. Okay, so this is what is meant by empirical formula. So when you look at the option, CH3O should be my answer. So the answer over here is option 3. Fine. You should be clear with this sum, so you shouldn't have any doubt in this sum. So in the same way for this sum also, only the mathematical part will be lengthier. Rest conceptual understanding is just a simple one, right? You shouldn't have any doubt in this question. Let's move to the next one. Next question is percentage of selenium in peroxidase anhydrase enzyme is 0.5 percentage by weight. Okay, so they have given us a new element which is like selenium Se. And then they have also given us the atomic weight of this selenium, which is 78.4. Fine. So obviously the molar mass will be equal, molar mass of this atom will be, of this element will be 78.4 gram, isn't it? They have given us the atomic weight or the mass number. So just plug in gram in front of it, you'll end up getting the molar mass of this element, which is selenium, right? What I need to find is then minimum molecular weight of peroxidase anhydrase enzyme is. So they have given you by weight 0.5 gram will be for selenium. Got it? If 0.5 is for the selenium, then what will be the molecular weight of that entire peroxidase anhydrase enzyme, right? So by ratio logic, I'll be able to do it. So first, let me put it this way. If I take like 100 gram of this enzyme, I'm just going to take only the 100 gram of enzyme. Okay, so if I take like 100 gram of enzyme, so in that 100 gram of enzyme, you will have 0.5 gram of selenium. Fine, logic should be clear. So out of 100 grams that I've taken, 0.5 gram will be for the selenium. I'll have to match it directly with the molar mass. Fine, so if I have to match it with the molar mass of the selenium, that should obviously be 78.4 gram. Got it? So 78.4, if 78.4 gram of selenium was present, then what will be the mass of the enzyme? So that should be the X that I need to find it over here, right? It should be clear here. In the numerator, I just compared with the selenium. So if 0.5 gram of selenium was present, then equivalent amount of molar mass of selenium will be equal to 78.4 gram, isn't it? Same way, if 100 gram was the total enzyme, so if for 0.5 gram of selenium, 100 gram of enzyme will be there, obviously. Then what should be the molar mass of that entire enzyme? That's what I need to find. So that will be the X, right? So just rearrange this one, you'll get the answer. Fine. So only tricky part is generating this ratio. That will be the tricky part for this question. Just rearrange it, you'll get the answer. Here X will be equal to 78.4 into 100 divided by 0.5, isn't it? Yeah. X goes to the numerator, same way 0.5 will come to the denominator. So in the denominator, I'll be able to substitute 1 divided by 2, isn't it? So this 2 will also go to the numerator. Just multiply it with 2, you'll end up getting the answer. That's it, finished. So if I do the multiplication, you'll have 78.4 into 2. That will give you 8.1614. 156.8. Yes, yeah, 156.8 into 10 power 2. That should be my answer. So if I do move the decimal place in front, you will have 1.568 into 10 power 4. The answer is option 1. Alright, it should be clear. Simple sum. Just the ratio logic, you'll end up getting the answer, right? I just know the molar mass of one element. I am just going to compare it with the entire enzyme. So if I just do the ratio logic, I'll get the answer, right? Simple, straight away, one step sum. You shouldn't have any doubt on the sum. It should be clear. Let's move to the next one. This sum is also simple one. Let me solve it. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process. Fine. So what I'm supposed to find over here is actually the moles of ammonia is something that I need to get. Okay, so just that if you get the equation, I'll be able to solve this one simple sum. So Haber's process is something we will learn in the upcoming chapter anyway. This is a simple primitive simple equation. So here I'm just going to combine nitrogen and then the hydrogen to get the ammonia, right? So the product will be like ammonia, which is like NH3. So to get this ammonia, I'll just take the basic two reactant, which will be N2 and then the hydrogen. Just balance this equation, that's it. You'll get it. So if I have to balance this one here, you'll have 3 and then this is like nitrogen 2, therefore 2 NH3. So this is the balanced equation for this Haber's process. Anyway, do not want to worry about these equations. As you learn chemistry, you'll end up knowing all those equations. Fine. So here what I need to find is the number of moles of hydrogen molecules required. So what will be the moles of hydrogen molecule that is needed to produce 20 moles of ammonia? So to produce 20 moles of ammonia, so here the product will be 20 moles. Okay. So this should be the X, isn't it? So if we do solve this one, I'll get the answer. So to produce 2 moles of ammonia, I need 3 moles of hydrogen. So here X moles of hydrogen will be required to produce 20 moles of ammonia. That's what they have given in the question, isn't it? Just flip it and do the cross multiplication. X will be equal to 20 divided by 2 into 3. Okay, if you do the solving, you'll get the answer to be like 30 moles, isn't it? So the answer is 30 moles, which is option 4. Got it? It should be clear. Simple sum. Only thing is you'll have to get the equation. Once you get the equation, straight away, ratio logic, you'll end up getting the answer. You shouldn't have any doubt on this question. Let's move to the next one. Next question is, the density of 2 molar aqueous solution of NaOH is 1.28 gram per centimeter cube. Fine, so they have given you 2 molar. So this capital M actually means molarity. Fine, so you will get used to this notation. Anyway, molarity means number of moles of solute divided by volume of solution in liters, right? You should know that formula that I've taught you in the theory part. So they have given us 2 molar aqueous solution of NaOH and they have given you the density of that solution, which is like 1.28 gram per centimeter cube. What they're asking us to find is the molality. The molality of the solution is, that's what I need to find, molality. Okay. Then they have given you some extra hint, which is molecular mass of NaOH, which is 40 gram per mole. So this is something that I could actually find it because, so for sodium I'll substitute like 23, that will be the molar mass. Oxygen is like 16 and then the hydrogen is 1. If I do add those stuff, you'll end up getting 40 gram per mole. Fine. So they have given you straight away. Anyway, I'll have to get the molality. So to get the molality, I should know the formula. What was the formula? Number of moles of solute, that will be in the numerator, divided by mass of solvent in kg, right? So I'll have to get only the solvent, which means solvent plus solute together, you'll get the solution. Here, I'll just have to consider only the solvent. Okay, so solvent is going to be my water. I'll have to get the solvent in terms of mass of solvent in terms of kg. Okay, so that's how I need to get it. So if I get that one, I'll end up getting the molality, isn't it? First, let me write the formula for the molality and I'll make it clear. So molality will be equal to number of moles of solute as usual. That will be in the numerator. Here in the denominator, you will have mass of solvent. Okay, so this will be in the convention of kg, in kg. Okay, right. Now to get the mass of the solute, okay, now to get the number of moles of solute, that's like super easy. They have given you straight away, which is like 2 molarity solution. Fine. So that will be like 2, that I'll be able to put it straight away. Only thing that I need to find over here is mass of solvent in kg. Fine. So to get this one, what I need to do is first I'll have to get mass of this solution. So to get the mass of the solution, they have given hint as density, right? So from the density, I'll have to get the mass of the solution. So 1 liter, it should be equal to 1000 centimeter cube, right? You should be clear with this convention. So 1 liter will be equal to 1000 centimeter cube. The reason why I am taking in terms of centimeter cube is because here they have given in gram per centimeter cube. That's it. Fine. So here they have given you like density, which will be equal to mass divided by volume. That was equal to 1.28. Got it? Instead of this mass, that is something that I need to get. Okay, so m is something that I need to get. That will be the mass of the solution divided by, yeah, let me write it as subscript. So mass of the solution divided by volume of the solution. What was the volume of the solution that was taken over there? So number of moles of solute divided by volume of the solution is going to give you the molarity. Fine. So that was like 2 capital M. So here in the denominator, I'll have to substitute the volume of the solution. Fine. Same way here, the convention was like centimeter in the numerator you have got like mass, that was in terms of gram. Okay, so that will give you mass of the solution in terms of gram. Same way this volume was given in terms of centimeter cube, isn't it? Therefore here in the denominator I'll substitute like 1000 centimeter cube for 1 liter. Got it? Fine. So mass of the solution will be equal to mass of solution will be equal to 1280 gram. Fine. Now I have got mass of the solution in terms of gram. What I need is mass of solvent in kg, right? So to get the mass of the solvent, what should I do? I'll have to subtract mass of the solution minus mass of the solute. If I do subtract these two stuff, I'll end up getting the mass of solvent, right? So mass of solvent, right? You should be clear with this stuff that I'm telling you. So mass of solvent will be equal to mass of the solution, that was 1280 gram, minus mass of the solute that I've added. So here initially it was like 2 molar aqueous solution. So generally when they are telling you like 2 molar aqueous solution, it simply means I have got like 1 liter of the solution. So here I have got 1 liter of this mixture. So that's why I've taken 1 liter to 1000 centimeter cube, from which I've just found out the mass of the solution. Okay, so the solution that I've taken over here is like 1 liter. So the mass of that 1 liter solution was equal to 1280 gram. Got it? So here I've got like 1 liter solution, and the mixed number of moles of NaOH was equal to 2 moles. So that was the solute that I've added over here. Okay, so the solute that I added over here was like 2 moles. Fine. So 1 liter was the solution, was the final solution, and then I have added 2 moles of solute into it. Fine. Therefore, the molarity, what will be the molarity? Molarity is nothing but number of moles of solute, that was like 2, divided by volume of solution, divided by volume of solution in liters, right? So 2 divided by 1 liter will give you like 2 molarity, 2 molar solute, aqueous solution of NaOH, right? So this is how I'll get the solution. Okay, so whenever they tell you like some base and acid in terms of molarity, what actually it means, if you take 1 liter of that particular solution, you will have so and so acid or base of moles of acid or base. Okay, so that's how you need to consider. Fine. So in this case, I've just taken, the final product was like 1 liter of the solution. So in that 1 liter of the solution, I've got like 2 moles of NaOH into it, which means that solution is 2 molar aqueous solution. So that's the understanding that you need to have. Fine. Anyway, now from this solution, I'll have to get away with the solute to get the mass of the solvent, isn't it? So what was the solute that was added into it? It was like 2 moles of solute that got added into it. So to get the mass of that solute, so this was the solute, isn't it? So to get the mass of the solute, what I could do is 2 into what was 1 mole of the solute, what was the mass of 1 mole of the solute, that was equal to 40 gram, right? So 2 into 40, so that will give you 80 grams, right? Now I have found the mass of the solute, which was equal to 80 gram, isn't it? Next, I can subtract the mass of the solute from mass of the solution. So that will be like 80 gram. If I do substitute that one, I'll end up getting the mass of the solvent to be 1200 gram. Okay, 1200 gram. Now I have got mass of the solvent in terms of gram. Next, I'll have to convert it to kg to get the molality, isn't it? So it should be 1.2 kg. Fine. So this stuff is done. Next, I'm just ready to do the molality. So molality will be equal to capital, no, small m, isn't it? Molality will be equal to number of moles of solute. So in this solution, in this 1 liter solution, I've got 2 moles of NeOH into it. Therefore, 2 should be in the numerator, which was the number of moles of solute divided by mass of solvent. Now I have just segregated solvent from that entire mass of the solution. So that was like 1.2 kg divided by 1.2 kg, isn't it? So molality will generally be represented by small m. If it was like capital M, that is molarity. Small m will be molality. Okay. If I cancel this one, I'll get the answer. So let me do the cancelling. So this will be like 1. This is going to be 0.6, isn't it? That's going to be 10 divided by 6. If I cancel this one, you will have 1 point. So for 40, you will have like 36. So that will be like 1.6, isn't it? So 1.67. That should be my answer. So 1.67. Molality is 1.67 small m. So the answer over here is option 3. Fine. The molality of the solution is 1.67 small m. Fine. So in this sum, also the mathematical part will be lengthier. So here they have given you 2 molar aqueous solution, which means in 1 liter of that solution, I'll have like 2 moles of NaOH into it. So that's the combination. Fine. From that, I'll have to get the molality. So to get the molality, number of moles of solute is actually 2. That stuff is done. Divided by the mass of the solvent in terms of kg. I'll have to get that one. So to get the mass of the solvent in terms of kg, first I should know the mass of the solution. So from the density that they have given, I found mass of the solution, right? So from the mass of the solution, what I did is I just subtracted mass of the solute to get the mass of the solvent. Once I got the mass of the solvent, I was ready to get the molality, which is nothing but number of moles of solute, that will be in the numerator. Same way, mass of the solvent in kg will be in the denominator. Just do the solving, you'll get the answer, right? You shouldn't have any doubt in this question. It should be clear. Let's move to the next one. This sum is tricky one. Here they have given a mixture of 2.3 gram formic acid. Okay, so they have given you an acid. You should know the molecular formula to it. And 4.5 gram oxalic acid is treated with concentrated H2S44. Fine. So to solve this sum, you should actually know this equation. Only if you know this equation, we'll be able to solve this one. Right. So here they have given you like 2 different acid. One is formic acid and the other one is the oxalic acid. So these two are carboxylic acid. Fine. In the 12th grade, we will learn aldehydes, ketones, carboxylic acid. So in that lesson, we will learn these equation. As if now for this question, I'll give you the equation straight away and we'll be able to solve it, right? So only concentrate on the solving part that I'm going to teach you. Anyway, you will not know the equation that I'm going to give you, right? I'll give you straight away, but you should know how to solve this sum once you know the equation, right? Got it? So this equation we will learn in the upcoming chapter. In the 12th grade, we will learn these equation. As if now, I'll just give you the equation straight away. Fine. The next statement is the evolved gas mixture is passed through KOH pellet. Fine. So this KOH pellet, what it will do is it will absorb carbon dioxide and then the water vapor in it. Fine. So rest product will be rest product, it will not be able to absorb it. So when you pass certain gas into KOH pellets or KOH that mixture, what it will do is it will absorb all the carbon dioxide and then the H2O in that mixture. Fine. So that's what it's going to happen over here. The evolved gaseous mixture is passed through KOH pellet, which will absorb the carbon dioxide and water. Then what am I supposed to find is weight of the remaining product at STP will be. So after the absorption of carbon dioxide and H2O, the rest product, I'll have to find the weight of that rest product. Okay, so leftover product weight has to be found out. Here, let me give you the equation straight away. So formic acid, the formula for the formic acid will be HCOH. Okay, so HCOH. When it is reacted with concentrated H2S44, fine. In the presence of concentrated H2S44, what it will do is it will undergo oxidation. I mean, it will split and then it will produce carbon monoxide and then the H2O. Fine. So it will end up producing carbon monoxide and then the H2O. Fine. You should, I'm just giving you the chemical formula straight away, chemical equation straight away. From this equation, you should know how to solve this sum, right? Then, with the case of oxalic acid, same way, that too is passed into concentrated H2SO4. The formula for the oxalic acid will be COOH, single bond, COOH. Okay, do not worry about the bonds and those stuff. Same way, in the presence of concentrated H2S44, this will form, yeah, this will give you carbon monoxide plus carbon dioxide and then the H2O. And so what will happen is one hydrogen and this OH will give you like H2O, and then CO2 will be evolved. Same way carbon monoxide will be evolved. Okay. So if this mixture is passed into then KOH pellet, what will happen is next this H2O, carbon dioxide and H2O will get absorbed in the KOH pellet. Only product that will be left will be carbon monoxide, right? So I'll have to find the weight of the remaining product, which means weight of the carbon monoxide has to be found out. Got it? So to get the carbon monoxide, I just first need to know the moles of carbon monoxide that has been formed in this reaction. That is something that I need to get. If I get the number of moles of carbon monoxide that has been formed in these two reactions, I'll be able to add those two moles. Finally, I also know the molar mass. By using the molar mass, I'll be able to get the weight of the product, remaining product. Okay. So here initially I have got like 2.3 gram of formic acid. That was the amount that was given over here. So that is like 2.3 gram. With the case of oxalic acid, you have got 4.5 gram. Yeah, right. So here you have got like 4.5 gram. So this entire stuff is going to completely dissociate, and it will form carbon monoxide and then the H2O. Right. So here first I'll have to get the number of moles that is present in 2.3 gram. If I know like number of moles present in 2.3 gram of HCOH, same amount of moles of CO will be formed. So if same amount of moles of CO will be formed, I know the molar mass. From that I'll be able to get the weight, right? Because all the stoichiometry is 1. Here 1, 1, 1. Same way here also you'll have like 1, 1, 1, right? Let me do the solving over here. So to get the number of moles, first I'll have to find the molar mass of this HCOH, right? So to get the molar mass of this HCOH, let me do the addition stuff. For hydrogen, it is like 1, and then for carbon, it is like 12, and then you have got like 2 oxygen into it, which will give you 32, and then you have got one more 1 into it, right? If I do add these two stuff, you will have 44 plus 1, 45, 46. So you have got like 46 gram with respect to the first one, right? So here, if I take over here, you'll have 45 for COOH. So here you'll have like 145, and then you have another 145. So together you will have 90. Yeah, 90 gram. That will be the molar mass of COOH. Now I'm just ready to get the number of moles that is present in 2.3 gram, isn't it? So to get that one, here in this step you will have 2.3. You will have 2.3 divided by 46, right? If I solve this one, you'll have 2.3 divided by 4.46, isn't it? 23 into 2 will give you like 4.6. Therefore, in the numerator, you will have something like the 0.1 divided by, yeah, 2, isn't it? 0.1 divided by 2. So that will be something like this, 1 divided by 20. So the number of moles that was present in 2.3 gram was equal to 1 divided by 20. The same amount of carbon monoxide will be formed over here, which is like 1 divided by 20. This stuff is done. Same way, let me do it for this part. So here we have got COOH, which was 4.5 gram, and the molar mass was equal to 90, isn't it? If you cancel these two stuff, you will have 0.1. 45 into 2 is 90, right? So 0.1 divided by 2, that will give you 1 divided by 20, right? Same way, you have got the same moles for half oxalic acid, so that will give you 1 divided by 20 over here. And same way, if you look at the product, you will have 1 by 20 moles of carbon monoxide formed. So together 1 by 20 plus 1 by 20 will give you 2 by 20. So that will give you like 2 by 20 of carbon monoxide, which will be equal to, which has to be equal to 1 divided by 10 moles, isn't it? So that was the remaining product which was left because carbon dioxide and then the water got absorbed because of KOH pellet. Got it? So I have got 1 by 10 moles of carbon monoxide. Now I'm just ready to do the solving to get the weight of the remaining product. Okay, so to get the weight of the remaining product, here if you look here, for the carbon, the molar mass was like 12 plus oxygen, it was like 16. So 12 plus 16 together, it will give you 28, isn't it? 28, 28. Yeah. So I have got like 1 by 10, which will give you 28 into 1 by 10. So then the mass of the remaining product will be equal to 2.8 gram. Yeah, the answer over here is 2.8 gram, which is option 3. Fine. So you should be clear with this sum. For this sum, do not want to worry about the chemical equation that I have written over here. While doing organic chemistry in the 12th standard, you will get to know these equations. Fine. So these will be the simple equation that we will learn in those chapter. So once you are thorough with those chapter, you will be able to get this equation. Only stuff that you need to know extra over here is you should know how to solve this sum, how I did actually solve this one. And then you need to know one more extra thing, which is when you have KOH pellet into it, carbon dioxide and water will get absorbed, water vapor will get absorbed, right? Fine, you shouldn't have any doubt in this question. Let's move on to the next one. This question is also a lengthy one. Here you have got, what is the mass of the precipitate formed when 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% NaCl solution? Okay, so you got like two different solution. They have given you in terms of percentage for that solution. So 16.9% of solution of AgNO3 is mixed with 5.8% of NaCl solution. So if this was the condition, then what will be the mass of the precipitate that got formed? First, I'll have to write this equation, right? Once I write this equation, I'll have to get the precipitate, right? If I know the precipitate, then I'll be able to get the mass of the precipitate, okay? So now let me figure out the chemical equation that is needed for this question. So here you've got AgNO3 that's going to mix with NaCl solution. So when it mixes with NaCl solution, the cations and anions will get rearranged. So it will form AgCl, that will be my precipitate. Same way you will have NaNO3. So generally nitrates and sulfates do not form precipitate because they are soluble in the water very well. AgCl will be the precipitate in this case. So AgCl will precipitate. I'll have to find mass of this precipitate. Got it? To find which one is the precipitate over here, you should know the solubility product. So solubility product or experimentally verified result, I'll not be able to get it, okay, through just by looking at this equation. But from the lower grades that we have learned, we know AgCl will generally be the precipitate, isn't it? Okay, so here AgCl was the precipitate. Same way NaNO3, so nitrate, sulfate, those are more or soluble in the solution, therefore they will not get precipitated. Fine. So anyway, end of the day, you should know AgCl is a precipitate in this situation. They are asking us to find mass of the precipitate, right? So if I have to know the mass of the precipitate, first I should know what moles of AgNO3 was there, what moles of NaCl was there. So if those two stuff combined, you will end up getting AgCl and the NaNO3. Okay, so if 1 mole of AgNO3 was there, 1 mole of NaCl was there, those two stuff will get combined and it will produce like 1 mole of AgCl, right? So first I should know the moles of AgNO3 and NaCl present in the solution, right? Got it? Fine. So to get that one, here they have given us in percentage of AgNO3 and then the NaCl. Here the percentage is measured with respect to the mass and then with respect to the volume, right? So this is like mass by volume percentage, which means mass of the solute, that will be in the numerator, volume of the solution in milliliters. Got it? You should be clear with the theory that I've taught you. So mass by volume percentage, therefore volume of the solution will be in milliliters. Okay. With the case of AgNO3, you will have mass of AgNO3 as 16.9 divided by 100 ml. Yeah, right? Divided by 100 ml into 100, that will give you something like 16.9 percentage, isn't it? So this is how you'll get the 16.9 percentage. But over here, I do not want to know for like this is like 16.9 gram. I do not want to know for 100 ml. I just need only for 50 ml. If it costs like 50 ml, just do the ratio. 16.9 gram will give you for 100 ml. And then I've just taken like 50 ml over here. Therefore, 16.9 divided by 2 will give you the answer for the 50 ml, isn't it? Then for 50 ml of AgNO3, that will be 16.9 divided by 2. If I do cancel this one, you'll have 8.45. Yes. Yeah, that will be 8.45 gram. So this was the amount of AgNO3 that was present in that solution. Same way I'll have to do it for the NaCl. So if I do it for NaCl, same thing, right? So NaCl, for NaCl you will have 5.8 gram divided by 100 ml into 100. That will give you like 5.8 percentage. Then for 50 ml, what will I get? Same way, for 50 ml you will have 5.8 divided by 2, same logic. Okay, so 5.8 divided by 2, that will be 4.9 gram. So this was the amount of AgNO3 and NaCl present in those mixture. So now I have got in terms of weight, mass. What I need to find over here is in terms of moles. So to get in terms of mole, first I'll have to know the molar mass. Okay, so this is where I'll have to do more solving. So then for the AgNO3, I'll have to get the molar mass. So if I have to get it for AgNO3, that will be 107 for the silver. And then for the nitrogen, it will be 14. Oxygen, that's going to be 16. 16 into 2 will be like 32. 32 plus 16 will be like 48. So yes. Yeah, correct. Now let me add this one. 8, 7 will give you 15, 9, 1, yeah, right, yeah, 8 plus 7 is like 15, yeah, 19, 1, 5, 6, 169. For AgNO3, the molar mass was equal to 169. Same way I'll have to do it for NaCl, isn't it? Then for NaCl, for sodium, that will be like 23. And then for the chlorine, that will be 35.5. If I do add these stuff, that 0.5, 3 will be like 8. So that will give you 58.5. Got it? So now to get the number of moles of AgNO3 in 8.4 grams. So to get the number of moles, let me do the next step, which will be something like this. Number of moles of AgNO3, isn't it? For AgNO3, you will have 8.45 divided by 169. Yes, this is going to be really lengthy. Anyway, I'll have to do it right. 4.9 divided by, yeah, 8.45 divided by 169. Let me try to do it straight away itself. You will have, let me do the multiplication. So 169 into 5. If I do multiply in this fashion, I'm just taking randomly. 45, 30, 34, yes, 3, and then 845. Ah, it matched. That's going to be like 8.45, isn't it? So you will have 845. Those two stuff will get cancelled out. It got worked out. So you will have 845, 5 into 10 power minus 2, right? 5 into 10 power minus 2, that was the mole that was present in terms of AgNO3. Then let me verify it for the NeACl. Okay, so that should be equal to 0.05 moles for the case of AgNO3. Next, let me do it for NaCl. So if I have to do that one, you'll have number of moles of NaCl. That will give you, so the gram that was present, which is like 5.8 divided by 2, isn't it? Oh, I've made a mistake over here. So it should actually be 5.8 divided by 2, isn't it? Yes, there was a mistake. So it should be like 2, isn't it? 2.9 gram. Yeah. So here, to get this number of moles of NaCl, I'll just have to divide it 2.9 divided by, you will have 2.9 divided by, you should have like 58.5, isn't it? 58.5. So if I just do the cancelling stuff, you'll get the answer. You'll have like 2.9 divided by 58.5, isn't it? Yes, let me move the decimal places and I'll just do it. So you'll have like 29, yeah, 29 divided by 585, isn't it? 585. If I have to solve this one, I'll just put 0 point, I'll add 1 0 into it. That will not work out. Then I'll just like add one more 0. You'll have like 2900. Yeah, if I have, let me multiply same way with 585 into 5. Let me figure out what will I get. So if I do multiply this one, you will have like 25 to 42 4 25. You have got like 2925, isn't it? If I do match this one with this number, then obviously it should be like 0.05 or 4 some 999, something like that, right? Therefore, yeah, it will be a good convention to match it with 5 itself. Therefore, you will have like 0.05 moles into it, right? So you have got like 0.05 moles. So in this situation, there wasn't any limiting factor over there. Both those AgNO3 and NaCl were present in the same amount of moles itself. Got it? So here also you have got like 0.05 moles. Same way, in with respect to NaCl, still you have got same moles, which is like 0.05 moles. So in both those conditions, I have got the same number of moles, which means you will have 0.05 moles of AgCl formed, right? And same way 0.05 moles of NaNO3 formed. Now I have got the number of moles of AgCl that has been formed. The reason why I found like two different coefficients is because, I mean two different, yeah, stoichiometry is because if one was available in a greater quantity, then this one will become the limiting factor. Therefore, only the same amount of moles will get reacted, right? So extra amount of one of the reactant is not going to get involved in the reaction. That's why I just found out two moles also. In this situation, both are same. Anyway, if that means 0.05 moles of AgCl will be formed, right? I'll have to get the molar mass of AgCl. If I do get that one, if I just multiply it with 0.05, I'll end up getting the answer. Okay. This sum is actually lengthy one with respect to the mathematical solving, right? Yeah. Now let me find it for AgCl. So for AgCl, you will have 107 for the chlorine, for the silver, and then for the chlorine that will be 35.5. Yeah, zero point 0.5, and then you'll have 2, right? 4, 142.5, isn't it? Yeah. With respect to AgCl, I've got like 142.5. That was the molar mass, and then I'll have to multiply it with 0.05, isn't it? So next step, let me do the multiplication, you'll get the answer. Yeah. So if I do the multiplication, you'll have 142.5 into 5. Yeah, 0.05 moles, isn't it? So you will have, where is it, 25? Yeah, right, isn't it? 5 is at 25 to 10, 12, 1, 5 is at 20, 1, 2, 7, 712.5 into 10 power minus 2, because I multiplied it with 0.05. So your answer will be 7.125 grams of AgCl will be formed. Such a lengthy question with respect to the solving, mathematical solving, isn't it? So the answer here is 7.125 gram. When you look at the option, the closest value is going to be 7 gram. Yes, 7 gram is the answer for this question, right? You should be clear with this question, right? With respect to the understanding, it is easy, but mathematical solving was lengthier. Here, you'll have to get the chemical equation. Once you get the chemical equation, next step will be finding out what was the gram that was present in 50 ml of the solution, right? Once you get that gram that was present in the 50 ml of the solution, now I'm just ready to find the number of moles, right? So then you find the number of moles. So in this situation, both those moles were same amount. Therefore, one of the reactant wasn't a limiting factor over here. So the same amount of AgCl will be formed, which will be like 0.05 moles. Once you multiply it with its molar mass, I'll end up getting the mass of the precipitate that got formed in this reaction, right? It should be clear, right? So this is a lengthier sum. You should be clear. You shouldn't have any doubt in this question. Let's move on to the next one. In this question, they have given us 20 gram of magnesium carbonate sample decomposes on heating to give carbon dioxide and 8 gram of magnesium oxide. So you have got a mixture which has 20 gram of magnesium carbonate, right? So once you heat it, I was able to produce carbon dioxide and then the magnesium oxide, and the magnesium oxide that got formed was equal to 8 gram, right? So that's the first statement. Then you have got what will be the percentage of purity of magnesium carbonate in the sample. So I just need to get the percentage of purity. So here this entire 20 gram isn't pure, there are some impurity into it. Fine. So with that impurity, it was able to produce 8 gram of magnesium oxide. Got it? So what I need to get is the purity of this magnesium carbonate, isn't it? So to get the purity, just to produce 8 gram of magnesium oxide, how much amount of magnesium carbonate is needed? Pure magnesium carbonate is needed. That is something that I need to get. Obviously, that will be less than this 20 gram, right? Because you are having impurity. Along with that impurity, you got 20 gram, right? So to produce 8 gram of magnesium oxide, it should be obvious that lesser than this 20 gram of magnesium carbonate is actually needed. So I'll have to get that term which is less than the 20 gram. So if I get the term to get the purity, what will I be able to substitute? In the numerator, I'll just put the pure sample that is actually needed and the sample that is given in the question, which will be like 20. If I just multiply it with 100, I'll get the purity, right? So that is how I'll do that. I'll get the purity, isn't it? If they're asking us to find the percentage of impurity, then in the numerator, I'll just have to subtract it. What was the impure thing into it? So 20 minus the found answer. Okay, so the answer which will give me the impurity, percentage of impurity. Here they are just asking us to find the purity. Therefore, the value that is needed to produce 8 gram, that will be in the numerator divided by the 20, which will be the sample that is given in the question, into 100 will give me the percentage of purity of magnesium carbonate. Okay, this one should be clear. While doing some, you'll get it pretty more clearly. So here you've got, let me write the equation. You have got magnesium carbonate. I'm just going to heat it. When I heat it, it decomposes into magnesium oxide, same way it will produce carbon dioxide as a byproduct, isn't it? Do not want to worry about this carbon dioxide, that will not be useful. So to get the percentage of purity, what I need to do is, first I'll have to get the molar mass with respect to magnesium carbonate. Okay, same way I'll have to get the molar mass of magnesium oxide. If needed, I'll use it. So to get the molar mass of magnesium carbonate, you have got 24. Okay, sodium magnesium, the atomic number of magnesium will be 12, double the amount will be like 24. That will work out in the situation. Then you've got carbon. So for the carbon, let me substitute like 12, and then for the O3 you have got 48. Got it? If I just do add this one, you'll have like 10, 14, 1, then you'll have 5, 6, 8, 84 gram. So the molar mass of the magnesium carbonate was equal to 84 gram. Same way for the magnesium oxide, you'll have like 24, and then for the oxygen, you have got 16, isn't it? So 24 plus 16 will get me the magnesium oxide. So 0 and then 1, you have got like 40 grams. Okay. So now I have found out the molar mass of the magnesium oxide. What I need to get is to produce 8 gram of magnesium oxide, how much amount of pure magnesium carbonate is needed. That's what I need to get, right? So to get that one, that's it. In one more extra step, I'll get the answer. So the next step will be 40 gram to get this 8 gram, isn't it? So to get the 8 gram of magnesium oxide, so to get the 8 gram of magnesium oxide, how much amount of pure magnesium carbonate is needed, right? So that's going to be X, which should give me 8 gram. In the with respect to molar mass, 84 gram will produce like 40 gram into it, right? So just this, with this I've got the required 100% pure, right? 100% pure MgCO3. So 100% pure MgCO3 that was needed was equal to, that's the X, was equal to 8 divided by 40, right? 8 divided by 40 into 84. Got it? So this much amount of magnesium carbonate is needed if it was pure. But in the situation, they have just clearly told us that you have impurity into it. While having impurity, 20 gram was like sufficient, right? So in the numerator, I'll have to put the exact number, the 100% pure one, which I have found out, divided by the amount that I have taken, that will be like 20 gram into 100 will give me the percentage of purity. If they have asked us to find the percentage of impurity, then I'll have to multiply, then I'll have to subtract 20 minus this number to get the impurity that was there in that magnesium carbonate, right? So here they have just asked us to find the purity. Therefore, I'll just put this number in the numerator, divided by 20 into 100 will give me the percentage of purity. Okay, the logic should be clear. I hope I didn't confuse you. So here you've got percentage of purity, right? So to get the percentage of purity, you'll have 8 into 84 divided by 40, right? Divided by, this is the numerator. In the denominator, you will have the sample that I've taken, that should be equal to 20 multiplied by 100, right? Yeah, let me cancel out. If I do cancel this one, you will have, let me write one more step so that we cancel this. So you will have 8 into 84 divided by 800 into 100, right? So if I do cancel this one, 0, 0, 0, 0 will get cancelled out. 8, 8 will get cancelled out. Then you'll just be left with 84. So the percentage of purity over here is like 84%, which is option 3, right? You should be clear with the sum. You shouldn't have any doubt on this question, right? Fine. So here they have given you a sample, which is like magnesium carbonate. I just burnt it. When I burnt it, I got magnesium oxide and then the carbon dioxide, right? What they're asking us to find is the percentage of purity. So to get the percentage of purity, first I need to know how much pure magnesium carbonate is needed. If I know that one, I'll be able to put it in the numerator. Same way in the denominator, I'll just put the sample that they have given in the question multiplied by 100 will give you the percentage of purity, right? So that's the logic that you need to know. Let's move to the next one. This question is based on the limiting factor of reactant that is present, okay? Let me read the question. When 22.4 liters of H2 gas is mixed with 11.2 liters of chlorine. Fine, so you've got like 22.4 liters of H2, which means 1 mole of H2 gas is mixed with half mole of chlorine gas each at STP. The moles of HCl gas formed is equal to. So I'll have to get how much moles of HCl to be formed. First, let me write the equation, balanced chemical equation. Here you have got H2 and then you have got like Cl2. That will give you 2 moles of HCl, isn't it? 2 moles of HCl has been formed. If this is going to be the case, I'll have to find it with respect to 22.4 liters and then the 11.2 liters. Got it? For the hydrogen, it is 22.4 liters. So in 22.4 liters, you'll have 1 mole of H2 molecule. With the case of chlorine, it's half, 11.2 liters. Therefore, you'll have like 0.5 mole. Got it? So this was the initial this was the beginning of the reaction. Okay, so initial condition, it was 1 mole and 0.5 mole. The product will be 0, isn't it? Once the reaction proceeds, obviously chlorine will be the limiting reactant over here because H2 is present in excess. Fine. So after the reaction has proceeded, when it is completed, you will have 0 moles. You will end up having 0 moles of chlorine left. In this case, as the stoichiometry was same, here in this situation it will be like 1 minus 0.5. So that will be the amount of H2 left after the reaction has completed. Yeah, obviously, right? 0.5 mole, if it reacted with 0.5 mole of H2, 0.5 mole will end up forming the product. Only the stuff that will be left is 0.5 mole of H2. Okay, rest all other things will get converted to the product, isn't it? Therefore, in this situation, it should be like 1 minus 0.5. You should be clear with this one. So we will do this kind of some more often in upcoming chapter, equilibrium and all those chapter. We'll do this kind of stuff. One of the reactant will be limiting. Got it? Here it might be new. We'll be doing this one again and again, and you'll get used to this kind of understanding. Here it will be like 1 minus 0.5. That will give you 0.5 mole of H2 present after the reaction got completed. Okay, so this will give you like 0. How much have reacted over here? 0.5 mole of both the reactant have reacted. So it should be equal to 2 into 0.5 for the product that got formed, which will give you like 1 mole of product that got formed, right? It should be obvious, right? So if 0.5 mole of those two stuff has got reacted, so in all those situations only 0.5 mole got involved, but in the product case double the time has to be formed. Therefore 2 into 0.5 will give you like 1 mole here in this case, right? It should be clear. So 1 mole of HCl has been formed. So the answer over here is 1 mole of HCl got formed, which is option 1, right? You should be clear with this sum. You shouldn't have any doubt. So altogether we have seen around like 9 sums, isn't it? 9 sums in this session. So the sums were actually easy, but the problem is we had lengthy mathematical solvings. Fine. Yeah. All the sums that we have seen should be clear to you. You shouldn't have any doubt in this sum. Just go through this lecture one more time if needed, if you have any doubt in this question. Got it? With this, the video gets completed. Bye.